All right, what's good? Welcome back to another stream. Let me hold up. Let me record. Check, check, check. Mic is on. Everything's working. I've been an amateur far too many times, and I've had the mic muted. But here we are, starting up another stream. Let's get it. We're gonna continue our build of the robot. Some of this I actually didn't have streamed. You'll see the discrepancies between how much how much I had progressed in comparison to where I ended. So let's take a look at this. You'll see right here. Let me see. Let me get this in frame better. Oh shit, I gotta flip this too. That's on some bullshit. Let me do a transformation, rotate 180 degrees, and that'll do it. That'll do it. Now if I go that way, we're more there. That should be appropriate. All right. So this is where I ended with the design of the robot, right? Before I go ahead and implement it and build it in CAD, I want to get a really thorough understanding of exactly how this mechanism, or well, these multiple mechanisms in combination are going to act. I want to know how the aesthetic is going to look, etc. Right? So moving forward though, I have some incompetencies in regard to like free body diagrams for mechanical systems, right? I can do the electronics and stuff easily. This is my forte, but I have a lot of knowledge needed to be acquired in regards to modeling mechanical systems. So that's gonna be kind of the focus of this stream, right? We're gonna kind of do some of that bullshit, and I want to do a free body diagram of this build right here in particular, so that we can understand various parameters, acquire an understanding of various parameters for the purpose of optimizing the build, right? Because optimization is going to be necessary if we hope to take this thing to market at some point in the future. Alright, so let me get rid of this garbage. Nobody wants that. That's not what we're here for. Okay, and all right, is my camera gonna focus? It's coming, it's focusing. Okay, so where to start? So essentially I have a couple things that I want to calculate. There's a couple things that I need to know. Okay, so let's, perhaps we should even write this down, right? So we require external forces, like we require certain drives and things of this nature. And so I want to know what the minimum external force required, or what is the minimum external force required to essentially operate or undergo the operation which I desire. Right? I'm not going to speak much about the operation. Perhaps you can deduce this yourself as we continue through this build. But I don't want to explicitly say for my own reasons, okay? Don't ask me, all right? So, okay. What is the minimum? What is the minimum required? We'll call this, what is the minimum force to operate? Let's call this the clamping force. All right, we'll give it a name, clamping force, right? Because we need something to go by. We have to name it in order to become intimate with it. So, all right, knowing this, let's begin with a free body diagram. Okay, so the reason I'm asking this question is because I'm going to inherently produce some torque, because the build of the robot isn't exactly, right? It's not exactly, what would you say, symmetrical. Okay, it's not exactly symmetrical, right? If we're looking at the Z, let's call this the Z axis here. So if this was our Z, if this will be our, we'll call this X, and then this is our Y, right? So can you not see that? Oh, my bad. Okay, so X, Y, Z, okay? So we defined our axes. Do I need to mirror this? That looks a little odd, doesn't it? I need to mirror it. Hold on. But regardless, we've defined our axes. Therefore, so the big question is looking at the z-axis. Okay, so y-axis is where we're going to produce some torque, or rather a moment, due to our variation in mass our asymmetrical mass along the x-axis, right? So we have a little more mass over here in this area, and we're going to have less on this side, okay? And so this is going to cause a moment, this is going to cause torque. So these are factors that we need to take into account when we're doing this build, because this is going to contribute, rather, we're going to use this. Whoa, somebody pulling into the grass right now? Oh, he's just about to back up. We're going to use this to our advantage to decrease the amount of external force, or rather our clamping force, required, right? So if we can alleviate some of the force required there, then this is going to decrease the amount of energy required, right? Because we're going to be driving the motor, which applies this clamping force. Okay, so this is all for optimization and efficiency, and for me to not have to, spend buku bucks on some ridiculous motor with a ridiculous spec, right? Who wants to do this? Okay, nobody wants to do this, so let's be smart about it and let's engineer smartly. Correctly, efficiently, whatever Lee you want to acquire. Bruce Lee, Jet Li, Jet Li in that one movie, Kung Fu movie, Jackie Chan, you know what I mean? Jackie Chan voices the monkey in Kung Fu Panda, whatever the fuck, wherever you want to take it. Dino in the chat. Bang! We got Dino in the chat. That's what I'm talking about. Okay, where's my transform right here? And then I need to mirror, rotate, no flip horizontally. Okay, right, now that looks better. Let's see when it renders on the restream, you know what I mean? Let's see, because right now it looks good to me, but does it look good to you? Does it look better now that I didn't transition. Son of a bitch, I didn't transition it. Let me know if it looks good in the chat. Let me know if that looks better in the chat now that I transition it. Yeah, that looks normal, right? Like, before it was a little bit, there's something off about it, nah? It was a bit odd. But whatever, alright, we back in it. Okay, so exactly what I was explaining was the offset in mass. If we're looking at the x-axis, the more mass on the one side and less mass on this side is going to create a torque, or rather a moment, along the y-axis, right? Looks great now. Fantastic. Thank you very much. Alright, so what I want to do is I want to do a free body diagram, and I want to understand what's going on here. So, where is my protractor? Where the fuck? Oh, here it is. Alright. Now, okay, so maybe I should start with the simplified model before I go into something a little more complex. Because really, I have to cover 3 dimensions. Ultimately, I have to cover 3 dimensions to operate. What is the minimum required external force to operate? Right, but we could start with something simple, a simplified version. But maybe I don't want to do that. I don't want to start with the simplified version, so let's not do that. Alright, first I'm gonna draw a box. I gotta really think about this. Draw a box to get some sort of reference, to essentially create a datum, although that's really more for manufacturing. I did not put that box in the right spot. I just want to visualize this, and so I can better understand. Why is this not... Okay, this isn't lining up. Tricky little paper. Tricky little cunt. Looks great now. Fantastic. Okay. Let's get my 3-dimensional box so I can perceive some planes, and I can better understand where my masses are gonna play a role. So let's just get this box rolling. Oi, cunt. Nope, not quite. Still messed it up. Okay. All right, so something like this. Okay. And now, shit. I really wish I had some, like, what do you call those things? Stencils? Some stencils? Oi, cunt. I done went and shit my knickers. Oi, cunt. Oi, cunt, you fucking... I'm sick of these soups. Sick of these soups, oi, cunt. With their capes and their flashy eyes and the lasers and shit. Oi, cunt, I'm sick of these soups. Okay, so three-dimensional. Okay, now let's, I kind of want to see some circular motion here. It's a little difficult to really get a good circle going on here. Something like that, whatever. Something like that. It looks like shit, like, you know, whatever. It looks like shit, whatever. You know, forgive me, I'm not fucking Picasso. I'm not, Michelangelo, but I'm working on it, alright? Alright, so now we got our circles, or ovals, rather, okay, I want to define, you know, we could do define this. Alright, so let's see this. Let's do a top view. Let's cover all aspects. Can you see that shit? No, of course not. Okay, so I did a circle. Alright, let's see, because I want to know exactly what degrees. So we're going to cover one portion here. Let me try to draw a little bit better to scale. Something like this, right? So one portion here. And then now it's like the question of what angle. Okay, so the question is what angle do I want to also cover these things? So here's our center. Okay, we'll just draw some, this is essentially arbitrary, and then we'll figure out what is ideal later. So we question this, and, well, do I not have something for this? I can't find my angle. I can't really find my angle necessarily. Wait, perhaps I can. No, I can't. Yeah, I can. Can I? Oh, no. No, never mind. The only thing I could do is, like, measure it. Okay, so one. That's good enough. Okay, so some angle here. Right, and this is where our other mass will be sitting. Can you see that? Yeah, fantastic. Okay. Alright. And essentially, I don't need to do any of that. This is what's happening right now. Okay, so at these various locations. Now, what's going to determine this angle, essentially? At what positions that we touch this cylinder, touch this circle? At what angles do we do this? In reference to the center. Is it necessary? Is that going to play a large role? Okay, so now if we were to mimic this here, bear with me, just bear with me. Okay, right. Something like this. We'll put our main one here. Right, and then again at some angle, let's see what in this would be the center of a circle. That's where we're touching. Something like that. Maybe we'll do him even. Oi, mate. I reckon I don't fucking like it, mate. It looks like absolute... I'm not even gonna say it. Forgive me. You guys, I be cursing too much, am I right? Right? It's there's better words, right? I need to have a stronger vocabulary and curse a little bit less, right? Do you guys appreciate the word fuck? You know, Do we enjoy this, or would you rather I use better words, better terminology? I don't know, or do we like fucking cunt? I don't know. Should we just go willy nilly and say what we want? Oi? I reckon. What do you think? What are your thoughts on this one? Okay, and then now we're here at some angle like this, and we're here at some angle like this. Like that. Okay, and then from where's our center? I don't know. This is not to scale, okay? This is not perfect by any means, right? Okay. So bear with me. Again, we have this, and then we'll have like this angle and this angle right here, and that's that's synonymous to this, right? They're essentially showing the same thing from different views. Okay, so now I have these points in space. Let's consider that this is my zero. This is my zero location, right? So 0. Okay, 0 on my axis. Okay, now let's draw a side view. But it's going to be difficult because I have these two masses at an angle around this circle, and so it's going to be a little difficult to model from the side view. But essentially, it looked like, and I have an offset, so let's see what that's gonna look like. So, that's why I'm thinking I should just model it in a more simplified manner. Like this. In a more simplified manner. Something similar to this. And then we're going to look at the center of the cylinder, the center of the pole. And we're going to decide, based on the center of mass here, the center of mass here, I want to know exactly what torque is generated. I want to know the torque generated right at the center of this cylinder. Essentially at this point, because this is going to alleviate the external force required in order for us to reach an equilibrium. Okay, so now what? How do we determine this? I mean, we know that torque equals our position vector cross our force vector, right? We know this is true. And so, our vertical vector doesn't really play much of a role in this, but we do have multiple positions here. So that's the thing, right? So if this was one of we have a symmetrical vector. So we have this vector, right? This is R. We'll call it R1. We'll call this vector R0, right? We have him, R0. Okay, and then we have R2, right? This position vector. R2, this position vector. So it is going to be determined, it is going to be separated into two vectors. Right, but then the, what we would consider, okay, let's define let's define our axes here. So we'll call this Y, we'll call this X. Okay, what does it matter? X, Y. Okay, like that. Can you see that still? Okay, so now if we're considering this, right, we're going to separate this into its two vectors. But then our vectors along the x-axis are just going to cancel, okay, because these two are symmetrical. All right, so that's going to cancel. Whoops, I drew that too far. So those are going to cancel. So what does that matter? So really, okay, we have this position vector here and this position vector here. Okay, so now these two are playing a role. This one cancels, right? So we'll call this R1 Y and R2 Y, like that. And then R0, well, it's essentially just along that direction, so R0 Y. Now we'll just leave it as R0. Okay, so that's very true. That's very true. And then now the force is at play. So if we're looking from the side view, these are our weight forces. We'll call this dub naught. We'll call this dub 1, which dub 1 and dub 2, right? So we'll draw it like this as if it's going into the page. Wait, right? No, that would be coming out, right? Going into the page would look like an X because it's going downward. We're looking at it from the top, so it's going to be an X, right? That's our vector. is an X, like that. And then that is dub 1. And then this one will be dub 2. But dub 2 equals dub 1. Ideally, right? Make that a vector. And then we have this one going into the page, which is dub not vector. Okay, and W, all right, the weight force equals gravity multiplied by mass, right? The acceleration of gravity multiplied by mass, which is approximately 9.8 meters per second squared. G equals 9.8 meters per second squared. Okay. Okay. Considering this, right? So we have these, they're playing a part on the torque. So we can combine everything. The only thing is like, okay, so what am I going to be doing? Am I going to be measuring my objects in kilograms, or am I going to be measuring them in pounds? Because if I'm not mistaken, pounds is actually a force measurement, is it not? Is it not? Does it not? Yes, depending on how it is used, pounds can measure force. Right. Contains, however, measuring weight, which is the force of gravity acting on a mass, you are technically measuring force. Indeed. Okay. Okay. So, what time is it? Okay. 6. Okay. Right, so what am I going to be measuring in? And now I have to calculate essentially, okay, in order to even do this, I have to calculate just about everything. So do I want to design first? Know every part which I will need? Yeah, so I actually think, because how do I calculate the weight of my object without knowing exactly how much mass is really going to be here? So do we really just design first and then optimize later? Holy shit. I think so. Fuck, okay. Okay, it seems that that's going to be the best route of attack. Okay. All right, let's all right, yeah, I guess let's just get back into the design for now. I think I need to design now and optimize later, because I don't really know exactly how much mass I'm going to accumulate. Sounds good for now. Good place to start. I mean, you really think so, or are you just saying that? You really think so? Because I don't really know, you know. Should we ask AI? Maybe let's ask AI something. Let's all right, when designing a robot, is it important to typical to design first and optimize later? I think, you know, I've even heard Elon Musk express a similar phrase, right? You just have to make it, and then you can make it good later. So I think that AI is going to verify. Yes, it is highly typical to design first and optimize later when building a robot. This strategy is often called getting it to work, then getting it to work well. Designers focus on a functional prototype before fine-tuning components. All right, well there it is. Sure as shit. Sure as shit. That's it. Let's continue with the design then. All right, sure as shit. All right, so this is where we are then with the design. Okay. And now we have this. I'm trying to think, is that still going to work as I intended it to? I believe so. And then that will go that way and something along those lines. Okay, right. We have another shock absorber right here from this direction. Man, are we... Should I go ahead and start design now, and then utilize the simulation? Yeah, and then utilize the simulation. Absolutely, absolutely. I still want to understand how to do some hand calculations. Like yeah, we are going to utilize the simulation, but like I still want to know how to do some hand calculations. Because like I feel as though if you're capable of doing the hand calculation, then you intimately understand those concepts playing a role, right? You understand everything that's going on, and it's the role of each part in the system, right? Because how else could you do a model, right? We can just throw a geometry together and simulate it, and just like that, which is it's highly efficient, and that is what we will do. But I do want to understand this, as a mechanical engineer would, right? So I do want to acquire that understanding, and I want to be competent, right? That's the whole purpose. So as much as this is a goal, it is also a project and a moment of learning. Okay, as is every moment in life, right? There's always something to take away from it. Okay, so honestly, I developed to a point that we could draw more, but truly, I think it's time to design in CAD. I really think it's time to design in CAD. So I guess let's just do that. Fuck yeah, let's go ahead and start designing in CAD. I do. What the hell? I do really want to go to the gym, but perhaps we'll save that. I want to get a workout in, you know what I mean? Okay, SolidWorks. Where is it? Bang. All right, let's open this up right here, and we'll get this rolling. So I'm going to design this in SolidWorks. Ooh, I forgot about my free trial. It's coming closer to an end. I ought to get that. Whatever the fucking term is, I can't think right now. Holy shit. I think I'm retarded. Okay. Alright, just letting this load up right now. Let me think. I'm going to have to mount another motor right here, so we're going to have to consider what that'll look like. For the most part, though, I think I have a fairly elaborate design that we can go ahead and move on to the CAD. Yeah, absolutely. I have a motor here. I'm going to have a motor here to drive this wheel. This motor operates the mechanism here. We have here's my rack, right? This motor will be connected to the pinion, which I've also decided another thing that we'll see about how that's going to go. Should I start a new one? Yeah, probably start a new one. All right, so we'll just model the frame first. We'll do the frame first. And then we'll do the various other components later. Oh, I don't know why that happened. Okay, here we are in SolidWorks, right? Are we gone? Yeah, we're gone. Okay. Extrude boss base. Yeah, let's start with the front plane. No, we're gonna start with the right plane. We don't want to look at the front, right? No. Start with the right plane. Okay. All right, we're just gonna need this. So, I wonder how that's gonna go. Surely it shouldn't be too difficult. Alright, I guess let's get into it. Now, one thing that I could do, like what are the typical dimensions of some material that I may use? Okay, let's just do that real quick. Let's just do a quick lookup. So Like what? Like we're looking at aluminum. I want an aluminum frame, and so let's go. I don't know. Let's just go to like Home Depot because it's accessible. Home Depot. Let's see what they have to offer. Let's see for like aluminum. I mean, what the fuck is happening right now? Holy shit. Aluminum. Aluminum framing. I don't know. Let's see what this comes up with. Aluminum framing. Let's see. And then let's see what the dimensions are for something atypical. What, like that? No. Trim channel? No. Right here, aluminum square tube, 8 foot, 1 inch by 8 foot, $47. It's kind of expensive, no? Okay, whatever. We'll roll with 1 by 1. We'll just do 1 inch by 1 inch. Okay, so that kind of seems like a typical thing. All right, so we'll move on with that. Smart dimensions. Okay, 1 inch by 1 inch. Ah, shit. I don't know. Fuck. I don't know any dimensions. Truly, I don't know what this is gonna be made of. Shit. Okay. I'm just kind of freeballing it here. I don't really like it. It feels wrong, but I mean, I guess so. All right, 1 inch. Okay, 1 inch. This first bit, let's make this let me just imagine it. 1 foot, 1.5 feet, 1 foot. Let's go 1 foot, 12 inches. We'll do that, 12 inches. Okay, very well. All right, bang. Let's keep drawing here now. Extrude. Okay, that. I wonder what that's gonna take. This is just a frame though. That's an entirely separate part. Right, so that's that. Where is that gonna go? Okay, so we'll do another one. Like this. Now how high is he gonna be? So first of all, I want to do this and I want to go let's think about this. What's the offset? Probably do it just halfway, right? Let's just go halfway, so 6. We'll leave that room. Okay, 6. Check. Smart dimensions. Bang. Okay, 1 inch. Check. Okay, just like that. So that, okay, like that. And then we're gonna need him, but would we do that after? No, not necessarily. Or would we? I don't know. Okay, that's gonna connect it there. That's gonna be higher. Interesting. So, is that 1 inch? It looks weird. Okay. Now, somewhere around here, no, he's gonna come further back, and then that. I don't know that those are at the same height. We're just gonna do this. So somewhere around here, we're gonna have this guy. Let's see how we're gonna connect these. What's that? Sketch fillet around the corner where 2 sketch entities intersect to create a tangent arc. What does that look like? Nah. I think I want this. Wait. I do want this, but how do you horizontal vertical angle? Orientation angle? And then nah, that ain't it. I did some earlier. This center point arc. Oh, wait. Tangent arc. Wait, let's try this. Ah, yeah, this is what I want. Okay. Bang. Smart dimensions. What's that gonna do for me? Nothing. Nah. 3.8. Yo! brother! Oh my goodness, what's up, my boy? What's up, my boy? You can share my stream on a Kick community. 1,000 followers, 800 viewers. 1,000 per stream? Ain't no fucking way, brother. I don't believe you. Ain't no fucking way. I'm just gonna go back to selling Sprite on the street, man. You're lying to me, bro. You're lying to me. I'm running out of cans, brother. I ain't making enough money to get by anymore. Alright, let's try 3. Ooh, I don't like this. That's not what I was trying to do either. Shit. Oh, no. I don't know how to use CAD. I don't like this. Let's can I get rid of this sketch? I just want it gone. I just want it gone. Because I need to start with the arc. Get out of here, bitch ass. Add me on Discord, Composer. Brother, wait, I think I remember you. Have you been here before? I can't really see. Oh, shit. Have you been here before, though? Alright, let's try this again. So, right, this is what I want. Okay, now that's at the 90. Radius. Okay. Alright. No, we don't want to do that again. Okay, so now that we have that, let's now define our radius. Come on, bitch. What's your problem? What the fuck? What's your problem? There. Let's make it 5. Yeah, I like that. Okay. Yeah, just like that. Okay, beautiful. Now what? Straight lines? Yeah, pretty much like that. Whatever. That's what we'll do then. Oh, I guess I could have continued drawing it. Whatever. Okay, so something like that. Okay, we're getting our frame down. It's looking a little bit like a sled. It's looking like a sled. No, I didn't want to do that. Shit. I'm all fucked up. Okay, there. I just want to move. No. What happened here? How'd that happen? Checkmate. Checkmate. Alright. If only I knew what I was doing. Alright, maybe let's exit sketch now, and then hopefully I can extrude this. I don't know. Extrude. Like, what am I extruding? I want to extrude everything. Yeah, I'm extruding nothing right now. 1 inch. Nothing is being extruded? What the fuck? See, why? Like, what's, why? Why can I not extrude anything right now? What the fuck happened? Sketch plane. Surface face plane. You stupid. What? Fucking retarded, bro. Are you kidding me? Okay, well, I don't know. That's all trash, right? Because I can't fucking extrude anything, so start a new one. I don't know. All right, let's try this again. Let's simplify some shit because I'm fucking sick of not understanding what the fuck is happening. All right. Sure, we'll start at the center, dumbass. Sure, we'll start at the center. Fucking stupid. Alright, yeah, like this. Alright, we're gonna draw a similar shape, and then we'll do all the fucking smart dimensions, not very smart, in a moment. Get out of here, bitch ass. Do all the smart dimensions in a moment. Yep. Alright, get out of here, bitch. Yeah, give me my arc, bitch. Yeah, something like that, bitch. Give me another arc, bitch. Yeah, something like that. Oh, okay, another one. Another one bites the dust. Another one bites the dust. Yep, I want to go straight up vertical. I want to go straight over horizontal. I want to go down vertical. Okay, let's do some smart dimensions. Probably can't though. Watch, I bet I can't. Let's go. 1 inch. 1. Okay, cool. Thank you, baby girl. Alright, smart dimension that shit, huh? Let's see. 1. Bang. Beautiful. Yep. Smart dimension that, huh? Yep. Yep. 1. Perfect. Ooh, beautiful. Yes. Okay, smart dimension that, huh? Let's go 6. I want 6. Yes. Okay, beautiful. Smart dimension that, huh? Check. Motherfucker. Smart dimension that, huh? 6.9. What? We can make him 6 too? Bang. Smart dimension that, huh? Beautiful. Okay. Smart dimension. Smart dimension that, huh? Look at the radius here. Can I change that? What happens if I do change that? Let's see. Let's see if I make it 5. What the fuck? What the actual fuck? Let's not do that. Let's not do that. Why did that move now? Motherfucker. Mother. Why is he up there? Alright, let's exit sketch and try to extrude. Well, would you look at that? Ladies and gentlemen, well, would you look at that? Fucking worked. Alright, 1 inch. Bitch. Ho. Bang. Alright, we're making progress. We're making serious progress right now. Drop it like it's hot. Drop it like it's hot. Alright, cool. I like it. I really like it a lot. Alright, I don't even know what the fuck going on right now. Let's transition real quick so I can look at other stuff without all of you weirdos looking at what I'm looking at. Okay? Got all your googly eyes on my shit. Okay? Little do you know though is that I can see you too. I can also see you. Yeah, I see what you're up to. I see what you're up to. It's not the same guy. It looked like he had the same Discord name, but he's different. He's a poser. It's not even a composer. He's just a poser. You know what I'm saying? Alright, enough of this. Enough of that. Starting to get real loopy here. Starting to get real loopy. Hey. Okay, what time is it? Man, I got stuff I gotta do tonight, man. I got stuff I gotta do tonight. Alright, let's keep doing this. So now what? Where would we go from here? I need to get that and I need to get that. But where is that connected there, Neil? Exactly where does that connect there, Neil? Alright, let's draw another extrude boss base. Yeah, we extrude off of here. Let me see. Something like this. It's gonna be constrained. It's gonna be constrained. I don't really want to constrain it. I need to come out here, something like this, and then yeah, we'll do that like that. But I only want to go half because I can mirror everything else. So I can mirror it all. About how far though, approximately. We'll define that with the fucking smart dimensions. We'll define that. Okay. 1 inch. Yes. All right. Smart dimension this bitch right here. We want this to be approximately. What? We want an overhang of a 2 inch. Let's keep everything whole numbers. You know, I like it. I like it like that. Okay. And then now we're going to make this. That's 10 inches right now. I actually want that to be 12. Let's make that a foot. Yeah. Check. Okay. What else? That's probably it for right now. Wait, that's actually it for right now. And then that's where the glides will be. And then that's the other rack for the rack and pinion. Okay. All right, exit sketch. Let's extrude this. What and how much will we extrude him? Let's say like, fuck guys. I don't really know. I'm just kind of freeballing it here. 5. That's a lot of material. Let's go 4. Yeah, okay. I like it. All right, we'll do that. Okay, beautiful. All right, right? Okay, so now, okay, we'll do this. Let me think. Go there. He's going to be connected to there. Exactly what the fuck is happening there, though. Right, all of that's connected. That slides on top. That's underneath. That's on bottom. So that goes straight back. Could have did that earlier, but whatever. Okay, so now I need to extend him a bit. Literally just going to be an extension of him. So let me just do that. Check, exit, extrude. Let's extrude him. Okay, so I just want to be like, that was 4 inches. Just go 1.5. Yeah, like this. Check. What, can I do a measurement? How do I do a measurement? Let's see. I need to get here. Now, what's the measurement from there to there? Where's my tape? Where's my tape measure? Instant 2D. Where is my tape measure? Well. Oh, you can't tell me how far those are apart? What is it? 9.72 for real? 9.72. Okay, fine. That's fine. That's fine with me. Features. Extrude boss base. Right here. Want to do a sketch. Shit. No, let me get back into view. Oh my gosh. This thing is fucking ridiculous. What? Oh. Yeah, that's where we are. Alright, I'm just gonna do like that, right? Check. Let's do our smart dimensions. Give me 1 inch. Bang. Give me 1 inch. Bang. Give me 1.5. Burn. Wait, why is it right there? Weren't those two level? Not added 1.5? I mean, they weren't, or they aren't level. Maybe that's fine. Whatever. Fuck it. Okay. Give me a 0. Yes. Exit dimension. Let's extrude. Oh fuck. What was it? It was 9 something. 9.7. Oh, 9.8. Wait, what? 9. Is it moving? Oh yeah. 9.8. 10? I'm confused. This smart dimension was bullshit. I'm confused. Anybody else know what's going on right now? I'm confused. So how long is it? 10.7, 10.7. No. 10.8. Yeah, sure, whatever. That works. There's a little bit of an overhang. Why is this glowing? Alright, I don't know, something like that, you heard? Something like that. I'm like getting further and further away. Alright, let's get back to the trimetric view. Bang. Or is that dimetric? Whatever, close enough. I'm afraid I can't do much more. Nearly coming to an end. 1 inch, 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 smart dimension, 1 inch, smart dimension, my ass, I want 0 offset right there, right there. Smart dimension, 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 smart dimension. How much is in between here? How much was that extrusion? I think it was just 2. Wait, technically I would do 2.5. Why? I think that's better now. Let's exit sketch and extrude. Extrude, 10 inches? Yeah, because he was 10. Oh, what did I do? I did 2, 3, 7. Should be 7, I swear. Bro. Wait, wasn't this, how much was that extrusion? No, that was 10. Wait, just 10 then. Yeah, right? Just 10. That's what it was. 10. Yeah, from this fucking line, wasn't it? Obviously it wasn't, though. 8, 9. Alright, must have been 9. I don't know, guys. I don't know. I feel like I'm just bullshitting shit right now. Alright. Yeah, this is, I mean, we're getting close to what I desire, but just kind of bullshitting shit right now. Okay, and then now that's gonna come out there. Okay. One inch. Yep, check. Why does it go away? Oh, what am I gonna do with a single point? Fuck, out of here. 1 inch. Okay, like that. I wanna. Can I get a. Brother. I think this thing's trying to rage bait me, man. 0, you fucking hoe. 0. Look at this little bitch. 0. No offset. Yes. Look at that little bit right there. That's no one to say. Alright, so we're gonna go out like that. Probably need some support there. Alright, exit sketch. We're just gonna extrude that. Alright, now the extent to which he extrudes. That's a good question. Right now it's at 9, 10. That guy's gonna need some support. That's not even long enough, is it? That guy's gonna need some support. That's not long enough, is it? Let me think. So like what? No, 12. At least a foot, but then what? 12. So we're out there. 12 a foot. Let's do it. You know, first design. Fuck it. Like, it's not gonna be great. We'll make it better later. First design. So what's it matter? I'll try to do that, but when I do shit like that, it always puts a constraint on me. Like, oh, you can't move this because of this. Oh, you can't dimension this because of this. I guess we're not such smart. We're not that smart of dimensions. Hey, whoa, you can't do this. I guess the dimensions weren't that smart. Weren't smart enough for that. Alright, and then we gotta come past this a good amount. So what, we're at 12 right now? Oh, yikes. 16. Well, now that seems unrealistic, right? That seems pretty unrealistic. It's okay. I mean, we can add reinforcements like here. Yeah, there's a number of things that we could do to optimize that. But fuck, first model, let's just do it, right? That's kind of the point that we're at right now. Okay, so now I want to make a reference geometry plane. Show me the planes. Let me see them. This plane. Oh, fuck. I just don't know what my numbers are anymore. this one, and we're gonna offset it by what? Flip offset, yeah. Wait, so 10. I need it right on the end of that guy. Back, front. 10, 9. That's it. Okay, perfect. 9. All right, cool. Check. All right, now I want to take this whole thing. All of it? Yeah. Okay, all of it. Wait. That's not how it's going to go. It's going to be like a mirror. Mirror face plane. No, mirror bodies to mirror. This is what we're going to do. Mirror face. Okay, mirror face plane is this guy. And then bodies to mirror is this guy. Wait, is that everything? Oh, that's everything. I mean, yeah, that's what I'm going for. Shit, see, okay, as I see it now, I realize that I made it too big. I made it too wide, for sure. That's okay, because it's our first model, right? Fuck it, right? First model. But, let's get rid of these. Yeah, it totally made it too big. How long have I been going for? Almost an hour. Ah, you guys, I got stuff I gotta do. I would keep going and keep building, but I got stuff I gotta do. Oh, why? Why must it be this way? Why must it be this way? But there, okay, we're kind of coming closer. Again, let's look at what my model is, right? Okay, the drawing, this is kind of what we're trying to approach. You obviously making the comparison here, I'll show you again. I made it far too wide. But that's the thing is like I guess that's the whole purpose, right? Trial and error. So as we continue to do more models, model it over and over and over and over and over and over and over again, we'll come to the realization that some of this shit just ain't gonna fucking work. All right. So we'll figure it out. We'll figure it out as we go. But that's gonna be the extent of this stream. I really appreciate it, you guys. I love you. And until